Today we are going to be shifting a little bit, so take off your scientist hat and install firmly your engineering hat, because today we're going to be learning about how to express yourself to other people in terms of circuitry. So we learned about all the different ways of how to make circuits. We learned about the 5 basic types of circuits, but we learned how to build them, and I'm sure at this point I'm filming long before you've actually sent me anything, but I'm sure you all have mastered the art of how to make your circuits. Today, however, we're going to talk about how to draw them in a way that other people can then take them and understand that and write it. And so, similar to in science in general, there are scientific languages. You know, it's how all scientists they when they have their discoveries, they give them a Latin name, which is because Latin. Sidebar here, Latin is the language of science, but that's not the language of engineering. And the language of engineering is very specific. When we have diagrams, so you have blueprints of a building, there is a way that's written, right? That's not written as art. So this is not quite an art class. This is more drawing, less art. So you're gonna need for this, well, first of all, I'd like just to introduce all of you back again to, yes, we have a camera up there, camera up here, same setup as before. Glorious, I know. So you're gonna need over here. You can see my hand. Excellent. We're gonna need some paper, some markers. We're gonna need all of the classic components. You're gonna have your we have our wire, our wires. We have our light bulb. We have our other wire. You need the other wire today. Keep that in mind. And please use your volt or amp meter. It doesn't really matter which it is. We're just gonna have it in there for added complexity. It's gonna be great. But first, we need to learn about what the different symbols are, what they mean in terms of when you see these written as in a when you see these symbols on a blueprint, you'll know what they are referring to. So the first, we're going to start off very, very simple, and that is wires. So in wires, so when you have a wire in real life, it's squiggly. It's different colors and shapes, and it can go all different ways. When you're drawing it, though, it's very simple. Whenever you're drawing a wire, you're going to draw a wire as a straight line. So it can go here, and then it can turn, and then it can go back wherever it's going. If it's going to multiple things, it stops here, and then goes somewhere else, and then, yeah. The point being is that when you see a thin black line on a diagram of this kind, this is a wire. Okay? Typically, we're going to start from the battery, go to the load, then go back to the battery, whatever it's going to do. Got it? Excellent. Next up. So, yeah. Next step. Here we go. So the next step is a light bulb. So there are 2 possible ways you can draw a light bulb on a diagram of a circuit. So here we go. Let's put that over there. And either way, you're going to have a line in, a circle, and a line out. I know that's not a perfect circle, but that's fine. And we're going to draw 2 of them. Here we go. You guys are welcome to use the same paper. I'm just doing this so that you can see. It'll be nice and large for the camera above, so you can see what I'm doing. Now, one way of doing it is you go in, you go up, you make a little loop, and then go back out. And the reason why this is shaped the way it is, because if you look very, very closely at this bulb, it actually has that shape in the filament itself. There's kind of a little filament of wires, a little tiny wire in there, that's the thing that glows, and so that's kind of a simple representation of that. The other one is much simpler to draw. It's simply an X. Both of those can represent a bulb, or a light bulb in a circuit. So you see a drawing of a house, and you see these wires going all over the place, and you see those are light fixtures. All right, so this is light bulb. Next up, we have this guy, which is a battery. And there's a way to draw a battery Next up, we have this guy, and this guy, and all the batteries you could possibly have, and there is a specific way you draw them in a diagram for engineering purposes, and the way is like this. There are 2 lines that are right next to each other. One represents positive, one represents negative. So there's a long and a short. The short is the minus, the negative side, the plus is the positive side. Right? Now, this is a single battery, the single cell battery. But if you were to have, say, two of them, right? They're next to each other, and there's no wire connecting them, they're just touching each other, you would have negative, positive, negative, positive. And then you would have the wires coming out from there. And so this can be as many batteries as you have, that's as many as those you would have. Sometimes if this is a specific voltage, you could have one very large battery that has much greater voltage than these dinky little things. You would then write that next to it. So over here, together, this is a 1 point. Excuse me. So this is a 1.5 volt battery. Together, it's 3 volts. 3 volts altogether. So you could write that next to it just to tell what kind of battery it is. But again, if it's more than one, you write more. If it's not, you don't. Okay, so this is a battery. Excellent, excellent, and excellent. The next one up is it's a very simple thing. We've done this before. We don't have a device that does it. We've simply done it by hand. And this is a switch. So a switch, like a light switch, if we're gonna cut that in right now. A light switch is simply something that opens or closes a circuit. That is why, on Shabbos, if you close the circuit, you're actually completing the circuit, which is a moha, and that's why it's usher on Shabbos. Most lights nowadays do not have fire in them, so it's not a problem with fire, it's simply a problem of making something, which is what happens when you flick that light switch, you close the circuit, and you let electricity flow, you are completing something. And so we did it by hand. We simply took our things and our bits here, and we connected them, and we almost connected them, unconnected them, connected them, unconnected them, and that's all we did. We didn't have a device that did that. We didn't have a little attachment that we plugged it into, had another wire leading to here, and then had a little arm. So you have them all over your house. I have them all over my house. Everyone has them all over their houses. They're one of the most basic things, but YBH does not have enough of them to give all of you your own very simple switch. So, in fact, later today we might actually build our own switch, but for now, for the time being, just let's make a let's show how to draw a switch on an engineering thing. And so you're gonna have a little dot, another little dot, wire coming out this way, wire coming out that way. Now, there's two formations of switch. It can be open, it can be closed. Start with the simple one. If the line just goes straight across, that shows that let's make these bigger. If the line just goes straight across, that shows that there is a switch there, but it is closed. Right? That is a closed switch. Electricity can flow across. But there's another kind also, and that is an open switch. And it's very, very simple. It's simply not connected. Right. Now, this switch could be a very complicated switch. It could be the simple arm thing that might see in the science lab next year. It could be the switch you have in your wall, but either way, it will be drawn like this. Right? That is what a switch is. This is an open switch. Right? If the switch is open, then there is no current flowing. It is an open circuit. If it is closed, it could then be a closed circuit. If you have a bunch of switches, and if one of them is open, it breaks the circuit. Try this at home. Try this. Turn off your lights. You've opened a circuit. Turn on your lights. You close the circuit using a switch. All right, moving on. So you know that funny box thingy that you guys got? So some of you have some of you it says an A, some of you it says a V. The one I have here has an A. This is an amp meter, or if it's a V, it's a voltmeter. So stay tuned for what those things mean. But for our purposes right now, all you need to know is that if you're going to put one of these into your circuit to measure the ampage, or the voltage of your circuit, all you have to do is you have a line, you have a circle, then you have another line, and that's for the wires leading out of it. And the actual thing, if it's an amp meter like I have, it'll have an A. Quick sidebar, an amp meter is actually called an anometer, but that doesn't matter for our purposes. I'll write this right here. And in case none of this isn't legible in post, we're gonna put the words on the screen. Anyway, the next up is a voltmeter, and it's exactly the same way. You would just put a circle and a V, another line. That is a voltmeter. That's all there is to it. Alrighty, everyone. And so now that you know all these great things, now we're actually going to do a wee bit of practice with it. So I'm going to build a circuit. You at home, I'm going to build a circuit, and then I'm going to pause the video. You're going to pause the video. I'm just going to put one of those screens with the bubbles floating and the calming music asking you if you're done. So I want you at home to draw the circuit that I'm making. So let's get started. Here we go. Alright, everyone, so now with that freeze frame in the corner, I'm going to draw with you, and if this is what you got, good. If not, then let's do it over. So here we go. We have the positive side on this side. We have the, and then we have wires going out over here, and then we have a bulb, and the wires go back over here. And that is it. That is our very simple circuit. That's the circuit that I just made. If you have that, good. If you have the other bulb symbol, that's fine as well. But that is how it functions. And now that we actually have a full circuit here, I just want to point out one other thing, and that is that when you draw a circuit, you should also be drawing the direction that the electricity is traveling. And so now this is a little bit weird, but bear with me for a moment. Science, for a very long time, thought that electricity moves from the positive to the negative. Now, since then, we've learned that the negative is actually the buildup of electrons. The positive has no electrons. The positive wants electrons. The negative wants to get rid of electrons, and therefore it flows through the circuit. So, in truth, it goes this way. But on all engineering schematics and all blueprints of building of houses, of how they're going to do it, and all the math that goes into how this works, it goes the other way. Why? Because that's how they started doing it, and they realized that it doesn't make a difference. Because if the circuit's going to flow, the circuit's going to flow. Right? So we're actually going to put the arrows, you can put little arrows on each branch of your wire, little arrowheads, and they're leading from positive to the negative side of your battery, right? That doesn't mean that's how the current is actually flowing, but it's how we draw it. All right, so now we're actually going to do the opposite. I am going to draw something and then put the calming, waiting music, and then I want to see if you can build the circuit that I am drawing. Alright, so here is the circuit I want you to make. Now you may notice here that I did put a switch in and we don't actually have a switch. So you have a couple of options of that. Number one, you can simply simulate it by not connecting this guy all the way at the final bit. The other option also is you can take, remember how we made for parallel circuits, we made our extra wires using tinfoil? So you can do that, and you can simply have two pieces of tinfoil that don't match, and then you can stick them down, and stick it up, and stick it down, and stick it up, and there you have a switch, your very own switch. So the rest of this, though, I'm not going to give you hints. I'm actually going to build it afterwards, but go ahead, build away. Alrighty, everyone, so as you can see, I have built the circuit that I've described. Okay, here we go. So we have the batteries set up as we've shown. We have the wire going from here, going from the negative terminal of the battery. We have, forget about that. We have this wire going from the negative terminal of the battery to the negative terminal of the amp meter. We have another wire going from the positive terminal of the amp meter to the light bulb. We have the light bulb to this tinfoil bit, which I'm using as my switch. This is the other arm of my switch because I don't own a switch right now. And there we go. So now we're going to connect them all, and let's see if this functions. This actually, hold on. So now, actually, we're going to build it and stop right there. How many of you lit your light bulb? I know I did in the building of this, but did you light your light bulb? If you did, if your light bulb was lit when you finished, you've read this wrong, because as you can see, my circuit, let's see if you can. As you can see, my switch is open. So my little arm here, is not going to be connected to this arm, therefore no current should be flowing and nothing should be happening. So we're actually gonna, there you go. That is our completed circuit. There is no current, there's nothing happening. But now, if you want, just for your personal enjoyment, go ahead and complete your circuit. There we go, and there you go. And as you could see just there, I'm going to do that one more time. As you can see, the amp meter reads right about 0.2. That's how many amps we're using right now. I'll explain all those things later on. I'm actually doing it today, but you won't see it until who knows when. Anyway, alright, so that is all the engineering bits for today, and now that you guys are these great engineers and you know what's what and how to do things, and you've practiced at least twice, I now have an engineering challenge for you. So for this week's challenge, what I want you to do is I want you to take the components that I've given you, the tinfoil and whatever else from around your house, I want you to make something practical. You can make a flashlight, you can make a night light, you can make something for a safety device for your bike, you can make something wearable. If you figure out how to make it flash, that would be very cool, but you know, that's a bit advanced. So knock yourself out with that one. So this is due next Monday. Next Monday, I will also be releasing a video of how I made my device. So in case you're having a very hard time, don't sweat it. Just continue on with the regular stuff, and you will have a chance to do that next Monday. So let's see what you come up with. I've seen amazing things from the lightning presentation. You guys went above and beyond. That was really, really amazing. So I am looking forward to see what you guys come up with for this project. Good luck.